All right, welcome back to KM6LYW Radio, the show about amateur radio or ham radio with an emphasis on digital or data modes, moving information back and forth using amateur radio, reimagining ham radio in the information age. Hey, today we're going to do a bunch of digital stuff. We've got something called the SDR Play. This is software-defined radio at its finest. In fact, this is a fairly new version of this, made in the UK. Let's play with the SDR Play today on KM6 LYW Radio. Yep. All right, welcome back. That's the cheap bumper music. I'm out of guitar jingles, so yeah, I had to pick up the bass. I'm not a bass player. I'm a poser when it comes to bass playing. All right, so SDR Play, let's mess with it. What can you do with software-defined radio? In fact, I've got one down here that we're going to mess with, and we're just going to look at a couple of bands, VHF, HF, there's a lot of cool stuff out there. It's different to everyone. I'm just going to share what I've learned about it. It's a fun little device. It's not cheap. It's like over $100. If you want, get the rtl-sdr version. That's like $20. It has some different deficiencies, but we can talk about that. So this is the device here, the SDR Play. It's really simple. The RSP1B is in Bravo is the new version of this. It gets a nice aluminum case. It's got an SMA input and a USB jack on it. So it doesn't really get any more simple than this from a hardware perspective. The real magic is on the inside. So in addition to this, you can get the rtl-sdr dongle. This one's a lot cheaper. This is like $30. This has a more narrow bandwidth. The bit rate's lower. I think this is more like 8-bit, where the bit rate and bandwidth is a lot higher on the SDR Play. The other big difference is the rtl-sdr dongle that most people use doesn't do HF, so you can't really do anything below 35 megahertz with this. But the SDR Play, on the other hand, is going to do pretty much the whole electromagnetic spectrum from a radio perspective. And we're talking down from, the kilohertz all the way up to gigahertz. So I don't know what the actual ranges are on this, but it's impressive. It really is impressive. Some other variants for software-defined radios are this little new elect thing. Actually, put a heatsink on this guy. It's just a USB dongle, and again, this is a lot like this guy, and it's also in the $30 price point range. So what is software-defined radio? Why do you even care? This doesn't look like a radio. This is just an aluminum box. I mean, what are we going to do with this thing? So it's just a receiver. It's not necessarily ham radio. This just receives all kinds of signals in all kinds of different modes and modulation techniques, signal widths. There's really nothing you can't do. It's like the ultimate radio receiver. Now, you do need a computer to operate it, so it has this single USB cable. So you're going to need some sort of software to operate your software-defined radio and start listening to signals. Again, you can't transmit on this. So this is for everyone. This isn't necessarily a ham thing. So let me disable this guy, and you don't need to look, because it's not going to do anything. It just sits there. We'll turn him off. All right, so here we are with some software that's actually driving the SDR Play device, and this is called SDR++. This is one that I like. It drives a lot of different devices. It'll drive the rtl-sdr out of the box, no problem. The SDR Play is kind of proprietary. I mean, they're getting better, but you do have to go download some drivers for it, and it's kind of a trick to get it to work with some software. I've got it working with SDR++. I've got it working with SDR Connect, which is the software SDR Play provides. I've got it working with GQRX, which is another piece of software. But for right now, for my money, SDR++, this is free software. This is a really cool way to use the SDR Play. So let's mess with this a little bit. I'm going to make myself a little smaller here. This is going to be some interesting production value. There I'm smaller. So this is SDR++, and at the top of the screen, we see a fairly wide portion. Actually, we're seeing the entire portion of the VHF 2-meter band here in the United States. In the UK, I know you only have about half of the VHF spectrum, the 2-meter spectrum. But on the top here, we see are all the signals that are out there. I don't think I'm on a frequency right now, so hopefully I'm not playing over my voice. But here's a strong signal here in the middle. This happens to be, I think that's the club repeater. Over here on the left, we've got APRS packet traffic. That's our digital traffic doing positioning and radio texting. We can see the entire spectrum from one screen here. That's one thing you can't do on the rtl-sdr dongle. The camera's not on. This will only see about half of the VHF spectrum. So if you want to see the whole thing, you got to pony up and get the upgrade to the SDR Play dongle. So I was just going to mess with this a little bit and just to see what this sounds like. Let's see, I'm going to go to, there's a signal here. I'm just going to click on it. Let's see what it sounds like.
But where did you get the May 4th date if they don't show the class?
So there's people talking on a repeater here.
They show the class.
I don't want to talk over it necessarily, but you can do
extra. They talk about
things like there's noise reduction,
there's
voice noise reduction, there's a high pass filter to get rid of the PL tone.
Too, but I'm not sure that.
That was my complaint last time, is you always heard the PL tone, and I did a video on that. It's like I kind of jerry-rigged a way to get rid of the PL tone so you could listen to the repeaters, and the SDR Plus software guys are like, hey, we implemented it. There you go. It's cool. So the open source software process is happening that fast, and this software is really mature and really cool. So I was really happy to get SDR++ working with the SDR Play. So if you guys aren't already familiar with SDR Play, it's modular based. It can be a little overwhelming at first, but once you get the modules that you're used to, you can get SDR Play as the source. This is the source. You can change the width of the signal you're listening to. That width can be anywhere from 2 megahertz, I think, up to 10 megahertz of width. So you can see entire bands with the SDR Play device. The LNA gain I kick up to max. The audio frequency gain amplifier I usually leave pretty low, just to get it to 95 dB. It's not actual dB, it's kind of relative to the full band. So there are all of the different modes this will decode. So this will do narrow FM, that's what it's doing right now. AM, it'll do wide FM. CW, I'm not sure how that works. I guess that's a really narrow filter. Upper and lower sideband, which is for HF. So there's lots, and that has a frequency list here that's pretty cool. So you can actually save all your favorite frequencies, club repeaters here. And then there's a lot of other modules I'm not even going to get into because it really is overwhelming. It took me a little while to get just the modules and get this set up just how I like. But boy, once you're there, it is pretty darn cool. So the important thing is the squelch. I don't know why I can't find that sometimes. You can kick this down until you get a little bit of static and then kick it back up just like any other squelch. And then let's go hear a signal.
If you're going to study, you got to do it before June 30th.
Yeah, the signal sounds good.
Maybe that.
So you can zoom in on signals too. Let's check this out. Let's go here, and I'm going to do the zoom slider.
So I got to scoot. So if you want to hold the fork down, Bob,
so there's the whole signal.
Don gets back or not. It's up to you.
I'll turn down the volume, but that's what an FM signal looks like. So you guys know the difference between modulation, right? So there's AM and FM. Those are the two big ones. So, audio is just a squiggly line, right, that goes to your speaker, electrical squiggly line. So in FM, we actually put a signal up, like here on the graph, and then we go back and forth. The signal frequency changes just a little bit, about 12 kilohertz. Goes back and forth. So this would be a 1 hertz squiggly line, and this would be about 10 hertz audio doing FM with the frequency actually changing, going back and forth. Now we go to decode an AM signal. It's just kind of the polar right angle to that. The squiggly line is the power level of a single signal going up and down. So you can see how there would be more noise. If an AM station's distant, it's going to be more quiet, right? Because there's not going to be as much power. Whereas FM, it's full power all the time, and we're just moving that frequency back and forth, and it's that shifting that's really giving us the squiggly line for audio. It was never really explained very well to me, honestly, the difference between AM and FM. But for some reason, that helps me think of it when I think of the audio as being a squiggly line. All right, so let's back up here. Hopefully they're not talking over to me too much. Hey, we can actually listen to APRS, or you want to hear what data sounds like? I don't know. It's not going to come through now. There it is. There's a packet. So you remember those 1200 baud modems back in the day? It's literally the same bell. tone. So that's actual data, messaging, ham radio texting going back and forth. And we can use software to decode that if we want. So this is SDR Play, and we've just been messing with the 2-meter ham band. Now we can change the frequency up here to be almost anything we want. What I might do is drop this. Let me kick it up a little bit. Let's get out of the ham bands. We're up into the marine band. The other cool thing about SDR++ is it actually shows the band and types of signals you're looking at here. So I know if I'm looking at 154 something, I'm in the marine band. This is also public safety. I don't know if this will come up. Let me turn up the volume.
Levi is valid.
Copy.
Can you guys hear that? I'm assuming, I think that's the sheriff, 155055. I don't know. I can kind of zoom in on it. And of course, they're not talking now. So yeah, we get the sheriff, we get the fire department here. In fact, we're in California, so this is really useful with when we have wildfires, right? So I'll see smoke on the horizon. I know exactly what frequency to go to here, and I get it crystal clear on the SDR. And I can also see the tactical frequencies right next to it. So if there's multiple fires, I can check on the frequencies for each fire. So really practical use for the SDR stuff. So, you know, I can keep going up here. It's going to be loud. I'm going to turn down the volume. It's not insane. This is actually a television signal. So again, we're at 4 megahertz width here. This is television. This is what TV looks like on the waterfall. I don't know, it's kind of cool. What would be really neat is we can get an ATSC decoder. I don't know, do you guys have an ATSC decoder where we could actually watch television based on this? Here is the 1.25 meter band. So this is the 220 band. I don't see anybody talking right here, but there it is. You know, we could actually zoom in on that and see the whole band and all the signals. So there it is, a 220 band right there. And we can keep going up. We can go up into the gigahertz if we want. So this is military aircraft. We can keep going, This is the 70 centimeter ham band. So we are looking at the UHF band. I guess that's what we call it here. We don't get a lot of UHF here in the United States. You guys using it like more in Europe? I don't know. Anyways, we can keep going up past the UHF ham band, and we actually get into business band. It's not labeled here, but you're going to see a lot of DMR types of radios. That's what all of these signals are. They're really obnoxious sounding. I don't have a DMR decoder going, but they sound like this. So that's a digital voice, okay? That's business band. And they're not all, it's not always voice. Sometimes it's just telemetry data. You know, it might be water levels at a dam or a weir. There's all kinds of interesting stuff there you can try and decode. But that's what those signals look like and sound like. This is actually our homeowners association radio right now. So I can listen to the homeowners association. They have DMR radios. And I happen to look up their license for this business band here. All right, so that's VHF and UHF. I've got two different antennas hooked up with an antenna switch over here. So I'm going to switch this over to the HF band. And you actually pick up VHF stuff pretty well with an HF antenna. So let's get down into these lower frequencies. This is stuff that propagates around the world. So let's take a look at the 20 meter wavelength ham band. And we can go over here. This is it. So this is the whole band. It's this little red stretch. It's, you know, down in the HF frequencies, it's pretty narrow, the useful bands. What I can do is stop this and then change the width of the signal down to 2 megahertz. All right. And then I have to start the SDR again. Now we're only looking at 2 megahertz of the spectrum. And I'm going to go ahead and zoom in on the 20 meter band. So this is 14 point something megahertz. I'll put that there. Let's zoom in so you can see the whole thing. So this is the entire 14 meter band at 20 megahertz. Now we're going to use single sideband here for HF radio. In fact, I'm going to kick up this minimum thing just to make the waterfall color nice. That's what this min slider is. There's also a max slider. You can get crazy with this. This doesn't change the gain or anything. It just changes the visualization a little bit. So I like to make it so the squiggly lines right above the red 20 ham meter band spectrum indicator. So what we need to do if we're doing HF is click on a sideband. So it's either upper sideband or lower sideband. Well, which sideband do you use, right? Is there some sort of, you know, international sideband selection? Well, there is actually. And the way I remember this is if you use upper sideband for anything greater than 10 megahertz, and you use lower sideband demodulation for anything lower than 10 megahertz. So that's the only way I can remember this. So since we are at 14 megahertz, we're going to be using upper sideband. I'm going to go ahead and click on USB. And then I am going to click on a signal here and turn up the volume for you guys. So since we're upper sideband, there's a signal right here. I'm going to zoom in on it. Hopefully this isn't too loud. So here's a signal. I am going to click on, actually that might be, this is digital. You don't hear digital stuff. Here's a signal right here so we can get it. I'm going to turn it up.
Boy, rhododendron bushes. Oh, like trees, you know.
And you notice it kind of sounds like Star Wars?
Rhododendron.
Boy, when they were
There it is. I nailed it. He's at 14268.
Over.
Of course, we're not going to hear the other side of that conversation. Let me flick up to this guy, see what he's doing.
Over.
Yeah. You got some AM stuff up there, it looks like, too. Let's check out this.
Over.
It's
Got
like
5-5. Good contact. N5 MLP. Go to the mobile.
so it's kind of like whack-a-mole. You see a signal, but you got to get on it fast. And so what's interesting, when you're using single sideband, when you see a signal, don't click directly on the signal. Click on the left edge of the signal if you're using upper sideband. Click on the right edge of the signal if you're using lower sideband. So upper versus lower sideband, it's really an AM signal, which has two sidebands. And to save power and space, it's like, well, it's kind of the same information. So we'll just get rid of one side of the AM signal. So that's why it's asymmetrical, and we call upper and lower sideband. All right, so hey, we did 20 meters. Let's check out, I just want to see how 40 meters is doing today. 7.0 something. So here we are on the 40 meter ham band, and now we're below 10 megahertz, so we need to be on lower sideband demodulation. So I'm going to click on LSB, and let's hear what these guys are talking about. I'm going to click on the right side of the signal because we're listening to the left half of the AM signal, the lower sideband of the AM signal. So let's hear this one. Of course, he just vanished.
That's a pretty neat board. I think it was $105 or something.
Yeah, I suggest getting one of those. Those things are. That's a really nice board. So S5 to S9, you're coming in very well sometimes and kind of scratchy the next. But thanks for checking me in. This is N6LAW. I'll call it 73, and we'll talk to you guys tomorrow. Yeah, I see the same thing.
So we're listening to amateur radio. So these people that are transmitting are licensed to transmit, okay, by our jurisdiction here in the Americas, which is the Federal Communications Commission. So in Europe, if you want to transmit on these frequencies, you're going to talk to CEPT, C-E-P-T, and get some sort of license and certification. But again, you can see there's this shortwave broadcast here. That's international radios. These are usually nations, states. We've got the 80 meter ham band, which really isn't active during the day. We've got some more shortwave here. In fact, usually on the top of 40 meters, 7 point something megahertz, I'll see the big AM carriers coming in from Asia, but it's not morning right now, so it's really not propagating really well. So we can keep going down. We're going down into the depths of the electromagnetic spectrum. We're at 3 megahertz. There's some interesting noise there. It's interesting. Now we're into AM broadcast. This is kind of interesting. So this is like, radio stations, commercial stuff. I can actually click on a signal here, and I'm going to go over to AM demodulation, and I can kick up the volume, see what this sounds like. I almost wish I hadn't amplified that. Anyways, that's whatever that was. So commercial broadcast, yeah, that's what you get. Welcome to Clear Channel. There's some talk radio stuff out there. Let's see, 15, 30. It has some bearable content. But again, this is broadcast. Let's see what this sounds like.
Well, there were men calling this out, and there were men who would be willing to step in.
All right, so we're getting all the way down to 1 megahertz, and this is AM broadband. We can also go up to, since we're talking about broadcast, let's go up to 90-something, which is going to be FM broadcast. So since this is called wide FM, so we need to go to WFM modulation over here to actually hear it. And we can see these huge signals coming in. These are massive. So this whole thing right here with these two bars on either side is an FM radio station. So I can click on the center of this, and we are now demodulating the analog portion of that. What's interesting is these two bars on either side. We'll talk about those in a second. Let's see what these guys are doing. Let's see if it sounds like. All right, there's music there that could be copyrighted, so I can't play it very long, but you can tell it's totally clear. Let me go over to talk radio. Let's see what this sounds like.
Why would anybody do it? And I have to tell you that I feel like a genius
So
every day from moving to Florida. New York is just
listening on
cannot dig it.
The reason I picked that because it's talk radio and it's sketchy as far as copyright goes, and this hosting provider doesn't necessarily like copyright violations. So it's hard to find a station that isn't playing music. So here's another one here we can do just for a second. All right, there it is. There's a little bit. I'm not even gonna say the artist. I don't want to get this tripped up. So I'm just going through some broadcast FMs. Totally cool. In fact, I will leave this on during the day. Go ahead and click on Decode RDS over here on the left, so you can see the auto text here. This is KKDO is always streaming live. Download free Audacity app today. I don't know. Anyways, this is like the radio text that you can get. Hey, I mentioned these little bars here. These weird lines, these rectangles on either side of these signals. We can actually decode that. What that is phase shift keying data for the digital format of the FM broadcast. So we can actually decode that and get digital. You ever notice in your car radio, the little HD icon pops on? I think this is an American thing. I don't know where Europe is at on this. It's called NRSC5 is the encoding. And it's an actual digital signal. And hey, since we do data in digital modes on this channel, we have to decode broadcast FM. So this is the analog version.
I'm going to tell you about Shinesty. You've never felt anything like this before. These are the best underwear.
So that's the analog version. So what I'm going to do is stop this, and I'm going to actually decode. Let's see if we can decode 93.7. There's a program called NRSC5, and we can talk about, I'll put the links down there. And I'm going to put 93.7, and we're going to decode that phase shift keying data on either side of that signal. See what this does.
Shinesty.com.
I feel good.
So that is digital.
Dad, are you singing
That's
to your
digital audio.
cereal?
Yes, I am. Like I knew that I would.
So hopefully you can hear me over this. So we can see the text. This is Sacramento's rock station. This is 93.7 The River. There's data in there. This is obnoxious. But we are decoding the phase shift keying. This is the HD audio that we were just listening to. So let me minimize this. Let me share some links with you guys real quick. So when you first get your SDR Play, I want you to download the drivers from sdrplay.com/API. You can get that for Windows, Linux, and Mac. It really is necessary to get the third-party software to load. You can get SDR Connect, which is a waterfall software interface. It works for Linux, Windows. That's SDR Play's thing. I still like SDR++. I did have to compile SDR++ because of the weird driver stuff. So for SDR++, you're going to go out to GitHub and just search for SDR++. The build instructions are there. You can install it, but I'm not sure if the nightly builds actually have the SDR Play enabled. So if you do compile this, which is unfortunate that we even have to do that, there are options here to add the SDR Play source as an option when you build the project. So I did do that. So I did build this from source, but I'm a software engineer, so it's kind of obvious. Also for NRSC5, for that digital decoding of the FM broadcast systems, there is a fork of that supports the SDR Play. This is by FVENTURI, Franco Venturi. Thank you for making a SDR Play version of the NRSC5 PSK HD radio decoder. I also had to do a command line option when I compiled this, and that's to make the SDR driver called SDR Play. So I think we did enough SDR stuff. We did software-defined radio. It is a really cool receiver. I'd really like to thank the guys at Ham Radio Outlet who sold me this. So Aaron, Ken, you guys know who you are. You guys are enabling my habit here. So I'm sure you guys know I was going to do an SDR video here. So SDR Play is pretty cool. Got it to work. I've been having a lot of fun with it. In fact, I just leave it on kind of all day. I plugged up to a couple of antennas here. Let me make sure I've got all the good stuff. Make sure we cover everything. So I also wanted to thank Jay, who put this together. Jerry, you sent me a image of your DigiPi with my call sign on it. So I actually sent a packet from using APRS through the International Space Station, and Jerry, a patron of KM6LYW radio, sent me a screenshot of his DigiPi displaying my station, which is 405 miles southwest. That's a pretty good throw for an APRS packet through the International Space Station Digipeater. So speaking of patrons, if it wasn't for you guys, this channel would not exist. Patreon.com/KM6LYW. Patrons get access to the DigiPi software SD card image, which you put in your Raspberry Pi, like this guy, and it implements every data mode we talk about on this channel. So the DigiPi SD card image goes to patrons of the channel. It does APRS, FT8, JS8 call, every digital mode you can think of, and it's all accessible. I'm looking for my phone here. It's all accessible via your Wi-Fi tablet or your phone if you have one on your desk. So it's really a good way to make amateur radio data modes accessible. The DigiPi SD card image, put it in your Raspberry Pi, plug it into any radio, and start using data modes from the comfort of your easy chair using your phone or Wi-Fi device. So that goes to patrons of the channel. Thanks, guys. So Steve, Mark, Andrew, Fu, Brian, Chris, Malcolm, Jim, Paul, Buddy, Robert, Kevin, Jeremy, Eddie, Aaron. I want to call out Aaron. He is a ham radio outlet guru helping us out there. So yeah, I actually bought this from those guys down in Sacramento, ham radio outlet. You guys are amazing. The number of patrons here is kind of overwhelming. This is a very humbling experience for me. So Keith, Bob, William, Paul, if you have a weird name, I'm probably going to read it out loud. Suds84, thank you very much. Rich, Rick. It's just, see, I'm not even halfway through. So all of these people are DigiPi users. That means all of these people are on the electromagnetic spectrum worldwide, either doing VHF packet mode, AX.25 keyboard to keyboard. Maybe you're doing HF modes. Maybe you're doing FT8. So we've really got a data or digital community out there using the DigiPi for data modes. Amateur radio isn't just about talking into a microphone and listening to static all day. We're bringing amateur radio into the information age. I can't believe I'm still scrolling through this. All right. Thank you, guys. Hey, this has been another KM6LYW radio production. Let me know how your software-defined radio stuff is going. I think it's kind of fascinating. Some days you don't want to always transmit. Just listen. There's all kinds of cool stuff out there. All right, so hey, my name is Craig. This is KM6LYW Radio. I'm in California, and I am clear.